There is a whisper in the equations, a bending of the possible, a hidden path in the dark forest of space and time. Call them wormholes. Not for how they look, but for how they promise to cheat the vastness. A shortcut, tunnel. A wound in the fabric of reality, stitched from light, gravity, and mathematics. Imagine standing beneath a sky scattered with stars, each one so far that even light, the fastest thing we know, takes years, centuries, eons to arrive. But what if distance was an illusion? What if space could fold like paper, and a path could open through the fold? Not around the mountain, but through it. This is not science fiction. It is science at its edge, where general relativity dances with quantum foam, and our best maps begin to blur. A wormhole is not a thing you build, but a possibility that space-time allows. A tunnel not made of rock or steel, but of the very geometry of the universe itself. These aren't tunnels in space. They're tunnels of space threading through the structure of reality, as if the cosmos itself is riddled with secret passages. Wormholes might link distant galaxies, or parallel realities, or even different moments in time. They could be stable or turbulent, natural or engineered. They could devour you in an instant, or deliver you home before you left. Some believe they formed in the early universe, bubbling into being as space expanded, then vanishing as quickly as they came. Others imagine civilizations far older than ours, leaving behind bridges in the dark. No one has seen one. But in the mathematics, they shimmer. A cosmic rumor. A riddle in the code of existence. Einstein and Rosen gave them form. Wheeler gave them wonder. Hawking gave them paradox. And yet, across decades of equations and thought experiments, a single idea keeps returning: that reality may be more connected than it appears. That the universe is not a flat map, but a folded, breathing labyrinth of possibilities. Tonight, we follow that riddle. Through black holes and paradoxes, through the boundaries of known physics and into the most wondrous idea of all, that the universe might contain doors, and those doors might open. This is not just a story about physics. It's a story about limits and what lies beyond them. It's a story about how far we're willing to imagine and how deep we're willing to look. This is Cosmic Canvas, where the universe is not only studied, but painted in meaning. In the language of physics, space is not empty. It stretches, bends, breathes. It is the fabric on which all things move: planets, light, even time itself. And like any fabric, it can wrinkle. A wormhole begins with that idea, that space and time, space-time, can fold. That two distant points could be sewn together by a tunnel, so that a traveler might step in one place and emerge elsewhere, instantly. It sounds impossible, yet the mathematics doesn't forbid it. Instead, it invites the possibility. Space-time can curve into a sphere, why not into a tunnel? If gravity can bend starlight, can it also open a passage? The name came from something simple. Picture a worm burrowing through an apple. Instead of crawling across the curved skin, it tunnels through the core, a shortcut, a wormhole. Physicists borrowed the metaphor, but their apples are galaxies, and their worms are geometry. The first to map such a tunnel were Albert Einstein and Nathan Rosen. In 1935, they discovered a solution in the equations of general relativity that described a bridge and narrow throat linking to regions of spacetime. It was called the Einstein-Rosen bridge, later a wormhole. But that bridge, elegant as it was, could not be crossed. It would pinch shut before even a photon could pass through. A door that slammed shut the moment it opened. Still, the idea lingered. Sometimes even a locked door tells you that a hallway exists. At its core, a wormhole is a hypothetical structure, a tunnel, made not of stone or metal, but of curved space-time itself. Two mouths, one throat, and a passage carved by the rules of Einstein's universe. It's not about moving through space. It's about bending space itself. To remain open, a wormhole would need something truly exotic. A form of matter with negative energy density. Not just unusual, but fundamentally opposite to everything we've observed. And yet in the strange terrain of quantum mechanics, hints appear. It's the Casimir effect. For instance, suggests that, in certain conditions, even the vacuum can push back. Could this strange vacuum force be scaled? Could we one day harvest negative energy to keep a tunnel stable? Or has nature already done it? Perhaps wormholes were formed in the chaos of the early universe. Or perhaps they are the relics of ancient intelligence. Either way, they remain among the most tantalizing possibilities in modern physics. In the next chapter, we'll explore the engines at either end, black holes, white holes, and the math that binds them. They are the most feared and misunderstood creatures in the cosmic zoo, black holes. Regions of such unfathomable density that nothing, not light, not time, not memory, can escape. To approach one is to approach silence itself, a kind of death. In the fabric of reality, and yet they are not monsters. They're mathematics made manifest. Solutions to Einstein's equations where gravity becomes absolute. Not chaos, but precision. A black hole is not just an object, it is a geometry. A place where space-time curls inward until direction itself loses meaning. At the center of a black hole lies a singularity, a point of infinite density where the known laws of physics break down, surrounding it. The event horizon. A boundary not of matter, but of knowledge. Cross it, and you do not return. But in theory, something remarkable happens on the other side of the math. If a black hole is a tunnel in, its mirror image, the white hole is a tunnel out. A white hole explodes outward, spewing light and matter, yet cannot be entered from the outside. It's the opposite of a black hole in every way, except one. Both are bound by Einstein's equations. And in the space between them, mathematically speaking, a throat can form. A bridge, a wormhole. These constructs are known as maximally extended solutions. They connect a black hole to a white hole via a passageway, a kind of cosmic corridor. This is not science fiction, it is general relativity, run to its wildest edges. These wormholes appear in the equations like daydreams hidden in logic, brief, beautiful, unstable. In most models, the throat collapses too quickly for anything to cross. But the framework is there. And just as a violin string vibrates with possibilities, so too do Einstein's field equations. Vibrating with geometries we've barely begun to imagine. Some physicists have proposed extensions. Add exotic matter, and the throat might hold. Add quantum effects, and it might even become a time machine. Others have suggested that rotating black holes, Kerr black holes, might naturally harbor passageways, twisting space-time into something traversable. But be warned, this is where paradox thrives, where timelines loop, where cause can follow effect, where stepping into one mouth of the wormhole might send you not just elsewhere, but elsewhen. In these equations, beauty and terror live side by side. Wormholes link not only space, but the boundaries of imagination and theory. In the next chapter, we will leave the chalkboard behind and step through the wormhole itself to ask what it would mean to travel one. Not as numbers on a page, but as passengers through the tunnel in the dark. Let us imagine for a moment that wormholes are not just mathematics, that somewhere in the quiet tapestry of space one waits, real and vast and trembling with gravity. A mouth in the dark, a portal not to dreams, but to destinations. The question is simple. Can you go through it? But nature rarely gives simple answers. Most wormholes in theory are fragile things, ephemeral. Born from equations, they collapse before a single atom can pass. The throat pinches shut the instant it forms, snapping space back into place like stretched rubber. But some ideas suggest otherwise. In the 1980s, physicists Kip Thorne and Michael Morris asked, could a wormhole be made traversable? Could it be stabilized, kept open long enough for something, or someone, to pass through? The answer tantalizingly was yes. If one could find the right ingredients, the main ingredient, exotic matter, form of energy that does the opposite of what gravity normally does. It repels, it has negative energy density, something never seen in bulk, but not forbidden by the laws of physics. In fact, quantum mechanics hints at its existence. The Casimir effect, where quantum fluctuations between two plates create negative pressure, is a faint whisper of what might be possible. If exotic matter exists or can be created, it might act like scaffolding, propping the wormhole open, defying collapse, holding the throat steady. If that scaffold held, the tunnel could remain stable. It could be crossed, but even then, the journey would not be safe. Space inside a wormhole is unlike anything we've ever navigated. The geometry is warped. Up is not up. Distance loses meaning. The walls may shimmer with quantum effects. Tidal forces could stretch a ship like taffy. And the bigger the wormhole, the gentler the ride. A mountain-sized wormhole might crush you. A planet-sized one might not. But there's more. Time behaves strangely in such places. As you move through the tunnel, you are not merely changing location. You are bending your relationship to time itself. Depending on how the mouths are positioned, you might arrive before you left. A wormhole can act not just as a portal through space, but through time. This opens doors the human mind is barely prepared to knock on. If we can travel through a wormhole, can we visit the past? Can we rewrite causality? And what happens if someone else enters behind you, loops back, and prevents your journey from ever beginning? These are not just sci-fi dilemmas. They are baked into the mathematics. Theories of time travel via wormholes suggest feedback loops. Closed time like curves where cause and effect become entangled, where a decision echoes forward, then backward, altering the moment that birthed it. Two physicists, these are paradoxes. Two philosophers, they are invitations. The universe may have safeguards natural laws that prevent such loops, or it may allow them, but subtly as probabilities, not certainties. Some physicists believe a traveler could pass through a wormhole and encounter another version of reality. Not a change to their past, but an arrival in a parallel timeline, a different branch. Others argue that the very attempt to create a paradox would fail, that the universe somehow self-corrects, that history resists editing. But even if the timeline holds, the risks are enormous. A miscalculation in the exotic matter distribution, a ripple in the quantum foam, stray particle caught in the throat. Any of these could cause the wormhole to collapse mid-transit. And what then? You are no longer in one place or the other. You are somewhere in between, lost in a geometry without anchor. Yet despite the danger, the idea persists, because there is something deeply human about this pursuit. This longing to step beyond the visible, to turn the impossible into a road. And there are reasons to try. Stable wormhole would be more than a curiosity. It would be a revolution. It's an interstellar shortcut, a bridge to distant systems, galaxies, epochs. A way to traverse the stars without waiting lifetimes for light. For a civilization advanced enough to construct one, wormholes could become infrastructure. Gateways, highways, threads in a cosmic web. The challenge then is not just can you travel through one, but can you survive it, control it, return through it? And if the answer is yes, who might already have done so? The Fermi paradox, our eerie cosmic silence, may hide in these questions. Perhaps we are alone. Perhaps others have already walked the tunnels we have only just begun to imagine. The first traveler through a wormhole will not be a tourist. It will be a pioneer on the edge of physics, carried by math, mystery, and courage. The price of failure is total. The reward is transcendence. In the next chapter, we confront time head-on. Because if wormholes are possible, then so is time travel. And in that idea lies the greatest paradox of all. Time to us feels sacred. A one-way river. It flows from before to after, from cause to consequence. It builds memory, history, experience, but physics is less sentimental. In Einstein's universe, time is not separate from space. It is woven together with it. Fourth dimension in a fabric that bends, stretches, twists. And wormholes, if they exist, may twist it completely. We've already seen that wormholes connect not just places, but potentially moments. That if the mouths of a wormhole experience different gravitational fields or different accelerations, they may tick at different speeds. This is not fantasy. This is time dilation, a proven consequence of Einstein's relativity. Fly one mouth at near light speed, then return it to its partner, and they will no longer be synchronized. One will be older, the other younger. Now imagine the tunnel between them has remained intact. Step through the older mouth and emerge into the younger one. You haven't just moved through space, you've moved through time. Congratulations, you've built a time machine. But with this, we enter dangerous territory. Because time travel breaks something profound, our sense of order. If you can go back, can you prevent the journey that took you there? Can you meet yourself, undo yourself, Welcome to the paradox. Imagine this. You receive a blueprint for a wormhole machine in the mail. You build it. It works. Later, you travel back in time and hand yourself the same blueprint. Where did the design come from? It was never invented, simply looped, existing without origin. This is known as a bootstrap paradoxian object or idea with no true beginning. It is not just a clever thought experiment. It emerges naturally from closed time-like curves, paths through space-time that loop back on themselves, permitted by certain solutions to general relativity. But there are even stranger questions. Someone could travel to the past? Could they go further than the wormhole's creation date? Most physicists say no. The tunnel must exist before it can be used. You cannot visit a time before the machine was built. That, at least, is a boundary. A safety rail. But what about interference? Could a traveler prevent their own birth, warn their ancestors, or cause events that erase the very cause of their journey? These are grandfather paradoxes, the classic time travel conundrums. Yet, the universe may be smarter than we are. Some theories suggest consistency constraints, that no matter what you try to do, you'll fail to change the past in any meaningful way. You can act, but the outcome will always loop back into alignment. Fate, perhaps, is not optional. This idea is known as the Navikov self-consistency principle. It holds that time is elastic, but not breakable. Others invoke multiple timelines, parallel universes splitting with each divergence. You go back and alter something, but you've simply branched into a new reality. Yours remains untouched. This removes paradox, but multiplies existence. If every potential timeline is real, then so is every version of you. Every choice, every possibility, splitting endlessly in the quantum sea. Still, even if paradox can be avoided, the ethical and existential implications remain vast. Should we travel in time? Should we witness the birth of stars, the fall of civilizations, the moments we were never meant to see? What happens when knowledge arrives before its time? When ideas from the future infect the present, would we be prepared for what the future shows us in return? Maybe this is why the universe hides its tunnels. Why wormholes collapse before they can be used. Why time machines remain stories, whispers on the edge of theory. Stephen Hawking once proposed a chronology protection conjecture. The idea that the laws of physics conspire to prevent time travel altogether, to guard the past from meddling, to preserve causality like a sacred thread. And yet, he left the door open. Not wide, but open. Because if wormholes are real, and if exotic matter can be found, and if we can tame the geometries of space-time, then time itself becomes a landscape, and we become its travelers. We have no evidence of time machines, no messages from the future, no signs of visitors from what lies ahead. But perhaps the silence is the answer. Perhaps they are forbidden. Or perhaps they came and we forgot. Or perhaps time travel doesn't change the past, it fulfills it. In the next chapter, we will descend from theory back to observation. We will ask the harder question, not can wormholes exist, but do they? And if they do, where are they hiding? We've walked the equations. We've imagined the tunnels. We've crossed space and bent time. But now we ask the question that drags the idea back to Earth. Out of chalkboard dreams and cinematic thought experiments, are wormholes real? Not possible? Not permitted by the math? But real. Out there. Hidden in the folds of space-time, waiting to be found? The honest answer is, we don't know. But in science, don't know is not surrender. It is invitation. No one has seen a wormhole. No telescope has captured one. No spacecraft has drifted past its mouth. But nature rarely announces her secrets. She hides them in plain sight, disguised as something else. For decades, we mistook black holes for myths. Now we've imaged one. A glowing ring around a shadow, burning in the sky, 55 million light-years away. So what might a wormhole look like? The truth is, we're not sure. They may resemble black holes, dark centers, gravitational lensing, a distortion of starlight. But unlike black holes, they might not feed. No jets, no devouring disk, just stillness. A perfect circle, a gravitational lens with no visible engine, a ghost in the geometry. Some physicists suggest that if a wormhole existed, we might spot stars behaving strangely, orbiting something invisible, or vanishing from one point and reappearing at another. Some even speculate about fast radio bursts, those brief, brilliant blips of energy from far away as signatures of something tearing across dimensions. Others go further. In 2020, a team proposed that a kind of wormhole could exist as a stable solution in quantum gravity models. Not shortcuts for humans, but tunnels for information. A bridge, not for spacecraft, but for entanglement. These are called ER=EPR wormholes. The idea that quantum entanglement and wormholes may be two faces of the same truth. That particles bound by spooky action at a distance are, in some hidden way, connected by microscopic tunnels in space-time. If true, wormholes may not be rare. They may be everywhere, woven into the quantum foam beneath all things. It's too small to travel, too vital to ignore, and yet we search for larger ones. Macroscopic wormholes, tunnels big enough for light, for ships, for minds. And we scan the sky watching for irregular motion, strange lensing, anomalous energy shifts. But reality is quiet. No confirmed signals, no throat in the void, no visitor from the other side. Does that mean they don't exist? Not necessarily. The universe is vast, not metaphorically vast. Literally, uncountably vast. And wormholes, if they exist, may be rare, distant, hidden in gravitational wells or curled up in unseen dimensions. Or perhaps they are unstable, forming and collapsing in microseconds. Gone before photons can scatter. Or perhaps they are camouflaged, built to be missed, veiled by civilizations far beyond our own, and this too must be considered. That if wormholes exist, truly exist, then so does the ability to make them, to place them, to shield them. That idea changes the equation, because now we are no longer just asking if nature builds tunnels, but if someone else already has. Could advanced life create stable wormholes? It's not just as transport, but as communication? A galactic internet made of folded space-time? Carl Sagan once asked a physicist to design such a thing for fiction. That physicist, Kip Thorne, did the math. And the story became Contact. But fiction, when built on solid theory, can point to deeper truths. So where does that leave us? With telescopes peering deeper, with instruments listening harder, with minds more open than ever before. We have no evidence, but we have models. We have motivation. We have wonder. Maybe wormholes are a bridge too far, a path the universe permits, but rarely walks. Or maybe we're early. Too young to see what elder eyes might notice, too bound by our own dimensions. In the end, the absence of proof is not proof of absence. It is simply a pause, a space between pages, breath before the next discovery. In the next chapter, we'll leave the telescopes behind and turn inward. Because wormholes don't just stretch space, they stretch us. They expand our myths, our metaphors, our imagination. Let's explore how this idea so strange, so slippery, has tunneled through the human mind for generations. Long before physics carved tunnels in space-time, human beings carved tunnels in myth. We have always imagined doors in the dark, portals through stone, sky, or spirit that lead elsewhere. Not just to other places, but to deeper truths. Shamans spoke of soul journeys through invisible tunnels. Ancient Egyptians mapped the underworld as a cosmic passage. The Greeks gave us Orpheus and his descent, a tunnel of music and mourning beneath the world. Even today, we speak of rabbit holes and looking glasses, wardrobes and stargates, bridges of Bifrost and wormholes of warp drive. Different names, same longing, the longing to pass through. Because to imagine a wormhole is to imagine escape. From gravity, from isolation, from the tyranny of distance and the slowness of light. But also perhaps from fate itself. So wormholes are not just a scientific idea. They are a psychological archetype, a yearning, a metaphor etched into consciousness. When physicists say tunnel through space-time, they are using the language of myth in the grammar of math. And fiction has returned the favor. In Contact, a machine born of equations becomes a journey through wonder. In Interstellar, love bends time as surely as gravity. In Stargate, ancient civilizations carve wormholes through stone. In Doctor Who, A police box becomes a tunnel through all history. These are not just special effects, they are mirrors. Reflections of our hunger to connect what was once divided, not only stars, but beginnings and endings, selves and shadows. And even now, in the language of science, the metaphors remain. We speak of bridges, throats, mouths, words of anatomy, architecture, intimacy, because a wormhole is not just a tunnel, it is a relationship between places, between moments, between the known and the possible. And perhaps that's why they haunt us. Because in every tale of a hidden door is the hope that reality itself is not closed, that the boundaries we see of time, of death, of space are not final. They are thresholds. Thresholds can be crossed. The idea of the wormhole isn't new. What's new is that we now have equations to match the dreams. Einstein gave us the tools. Wheeler gave us the metaphors. Hawking gave us the limits. Thorne gave us the path. But the idea has always been with us. In the ink of ancient manuscripts, in the silence of monastic caves, in the pause between heartbeat and breath. To imagine a wormhole is to believe that there is more than what we see, more than what we measure. It is to believe that the universe is layered. It's not flat but folded, not mute but humming. And that some doors, if knocked on gently, might open. So we write stories. We paint galaxies inside glass. We build equations and call them theories, but what they really are invitations. To explore, to wonder, to feel small and infinite. Because wormholes in the end are not just about physics. They are about faith, not religious faith, but the faith that comes from curiosity. From imagining beyond the given, from asking endlessly, what if? In the next chapter, we return to that question, not in story, but in paradox. Not in metaphor, but in math. Because if the universe is threaded with tunnels, what is it made of? And what happens to free will if all paths can be connected? We've followed the wormhole through space and through time. But now, we follow it through something stranger still, the self. Because if wormholes can bend time, if they can loop events, split timelines, or connect moments that were never meant to touch, then what becomes of choice? What becomes of you? In a world without wormholes, our lives unfold like stories. Linear, sequential, coherent. We make choices. We live with consequences. We believe in cause and effect. But the wormhole does not respect that simplicity. It folds the story, loops the sentence, takes the end and stitches it back to the middle. If you step through a wormhole and return before you left, have you changed something or merely fulfilled something already written? Physics offers no clear answer. Some models say time is fixed, immutable, that no matter how far you bend it, you cannot change what must happen. That all your choices past, present, and future are already woven in. Other models say the opposite, that every possibility branches, that every turn of the tunnel splits reality, that somewhere, some version of you always chooses differently. And in that fractal cascade, free will becomes not an illusion, but a fountain, endless. The quantum world already hints at this. Electrons don't choose paths until they're observed. Particles exist in probabilities, not certainties. The future is not fixed until it is. Now imagine layering wormholes on top of that, connecting not just possibilities, but collapsing them into loops, folds, collisions. You reach backward to warn yourself. You arrive too late. You try again and again, each effort spawning a branch. Is that freedom or futility? Are you the chooser or the echo? Some theorists propose that closed time-like curves, wormholes through time, don't erase choice, but trap it in self-consistency. You can act, but only in ways that fulfill what already is. You are free within the boundaries of what must be. A strange kind of freedom, like a melody that must resolve in the same key, no matter how far it wanders. Others suggest a multiverse without rules. Every version of you plays out. Every contradiction finds a timeline. Every tunnel leads to a new self. But then, what anchors you? What defines you in a sea of selves? Are you the sum of all versions, or just the thread you're following now? Wormholes challenge more than physics. They challenge identity, agency, soul. Because if you can visit a version of yourself who made a different choice, what happens to regret, to forgiveness, to responsibility? And if someone else changes your past, what becomes of the life you thought was yours? It is easy to get lost in these questions. They are not merely scientific, they're existential. And yet they are necessary, because they remind us what wormholes truly represent. Connection. Not just between points in space, but between truths, between interpretations of the self, between paths taken and not. The presence of a wormhole means that no boundary is absolute. Not distance, not time, not even the story you tell about yourself. And in that recognition, there is something profound. Maybe free will is not about having infinite options. Maybe it is about meaningfully choosing, even when paths are entangled, even when outcomes are uncertain, even when the tunnels are twisting in the dark. To be human is to choose in a universe that does not guarantee we matter, and still, to believe we do. That belief, unprovable, unshakable, may be the greatest force in the cosmos, stronger than entropy, stranger than gravity, more enduring than time. In the next and final chapter, we close the loop. We return not with answers, but with something far older and far more powerful. We've followed a thread through the dark, not a path of certainty, but of possibility. From black holes to paradoxes, from physics to imagination. We've wandered through the idea that space and time might not be limits, but invitations. And yet, after all the theories, after the glimpses and guesses, one truth remains. No one has ever seen a wormhole, not through a telescope, not through a lens, only through the mind. They remain a hole in the map, an open space in our understanding, where something extraordinary might dwell. But that hole is not failure. It is a sign of life, a breath in the cosmos that says, you are not finished yet, because wormholes are more than tunnels. They are symbols of questions we still dare to ask, of distances we still hope to cross, of truths we may not be ready to find, but still reach for. Perhaps we will never step through one. But the act of imagining them reminds us that the universe was never meant to be flat or final. It is a work in progress. So are we. We may not know if wormholes are real, but we know that curiosity is. That is how maps grow, not by filling in the edges, but by seeking what lies beyond them. In the end, a wormhole may not be a hole in space, but a hole in certainty. A place where we remember that the most powerful force in the universe might be the question we haven't yet asked. This is cosmic canvas, where the universe is not only studied, but painted in meaning,